We are back with another stream. Build in public, building Project Zima, which is a mobile on-chain trading app powered by Account Abstraction. Today is going to be a bit exciting. We're going to be doing finally implementing Account Abstraction using Biconomy. Before we begin, as always, if you enjoy this channel, if you like what I'm doing, please make sure to like, subscribe, and comment so I know, and that lets me know so I can continue making more videos. So let's jump into it. So Biconomy, I've got their docs up here. Biconomy is a SDK for account abstraction. I've seen quite a few different options popping up here, but for my part, I've tried out Biconomy and I think they're pretty good. So let's jump into this. We're going to need to do a little bit of scaffolding first. So let's get started on this. First, we need to install the packages. So we're going to need Biconomy bundler. We will need Biconomy paymaster, Biconomy account, and Biconomy modules. I think that is what we need. So first we will want to instantiate a Biconomy smart account object. I'm going to do that through a context, so we have access to that throughout our code everywhere. Of course, you are free to do it as you wish, but let's do this. So export type context. Let's call that smart account. Whoops. Biconomy smart account. Whoops, I think I had a typo here. Biconomy underlay. Let's just do all of them. V2, and we'll have it also potentially be null. Okay. And account abstraction, it's typically made up of, we've got two components that we need, which is a bundler and a paymaster. So let us define these in such a way that we have multi-chain compatibility. So we'll define it as a function that takes in, let's use chain ID, and we'll return a bundler object which takes in a bundler URL. For this bundler URL, I got mine through the Biconomy dashboard, I believe. It's free to sign up. You can just check it out. I'll leave the link in the docs, link in the bio rather. But I have this pre-set up already with my own key for my bundler. You'll have to get your own. And what's the last field we need is the entry point address. We'll just use the default entry point address. Oops. And we'll need to do the same thing for the paymaster. So get paymaster, and that'll also take in a chain ID, so that way we have a different URL for each, a dynamic URL for each chain ID that we might need. We'll need a Biconomy paymaster. Paymaster URL. And I've got this somewhere as well too. And think that's all we need actually for the paymaster. All right, and then that's good. And then the last thing we'll need is, of course, our smart account object, but we'll just initialize it as null for now. Smart account equals, oh, sorry, let's call this Biconomy context. Biconomy context, and that will take in a smart account, and we'll initialize that to null. Equals to create context of type context. Lowercase. And that looks pretty good for our context. So together with that, we will also need the provider. So let's jump in and do that too. Biconomy provider. All right. So what should we do here? So const Biconomy provider. Smart account. Smart account. Now we'll use state here. Biconomy smart account v2. Or no. Why not start that with no? What else will we need here? Let's get the chain ID. And okay, so let's initialize this. Okay, so let's define connect. Let's just define this first. Biconomy provider. Start with this. Okay, so first we'll need to create a ownership module. So mod equals to CDSA module dot create. Default ECDSA ownership mod. Whoops. Right, and we had an issue here last time. So signer here expects a Ethers signer. However, if you've been following along on this stream, we actually use Viem, which I actually prefer over Ethers.js. Primarily because they have, I think, better documentation, but there are some issues because some packages expect Ethers providers or Ethers signers, but not the VM version, which are public clients and wallet clients. So we need a way to convert from one into the other. Luckily, if we look at the Wagmi docs, there actually is a little, some helper function tucked away down here that details exactly how you can convert from VM clients and providers, clients and wallet clients into signers and providers. So we will go ahead and do that. So I'm going to copy paste those in. So let's make a hook for this. Let's call it adapters. Sorry, excuse me. Excuse me. And let's do providers first. Use Ether's provider, and I'm just going to copy paste this in from Wagmi. And that was good. And we also need the same thing for use Ether's signer. And I think that is good. So now we can here call use Ether's signer. Let's use Ether's signer. Did I export this? Export function, use Ether's signer. So actually I want to do that here. Ether's signer. Okay, const Ether's signer. And I think that takes in the chain ID I said. Sorry, like this. There we go. And now this should be happy. Oh, okay, we need it to be let's see if signer, let's just do that. Actually, yeah. Not signer, rather, Ether signer. There we go. All right, now it's happy. And so that's our ownership module. We also need to create the, now let's create the smart account. So const Biconomy smart account. We've got bundler, which now we'll take our get bundler that we defined earlier and pass in our chain ID. And chain ID, can it be undefined? No, I think we're good. Paymaster, we'll do the same thing, get paymaster from our function we earlier defined, chain ID. What else do we need in here? We need our entry point address, which is just going to be the default entry point address. And we also need our default validation module, which is going to be the module we defined, and the active validation module, which is going to be same. All right, now we've got the smart account object here. So let's just check, let's set it first. Account to Biconomy smart account. And then of course we want to run it. Am I lining up correctly? Here. And let's put a dependency array in here. Anytime the signer changes or chain ID changes. Sorry, not signer, Ether signer. And yeah, that looks pretty good. Let's give it a little bit more space. That looks pretty good. And then the last thing I want to do is return our Biconomy context.provider. And we will also need the children up in here. Let's get this from, just copy paste. Get this. And now we've got access to the children, right? Yep. There we go. And I think we're good. Oh, and we export it. Export default Biconomy provider. And I think we're good. So now we should be set up on our Biconomy provider. And of course, let us define it here. Let's put this outside. Biconomy provider. And why don't you define it? All right, I think we're good. Let's test this. I want to see whether we, component use needs use state O. And are we talking about here? Do we need a use client here? Use client. Let's see. Nope, still missing one more. Maybe the context? Oh, no, we're good. Okay, I think it just took a while to load. Ignore this. Okay. And let's now test this with our account address. So previously here, I just put in our dumb wallet address. So you see here, this is my EOA address. And I kind of just, was scaffolding this and I put in our own EOA address. But what I really want in here is a smart wallet address. So in order to do that, let's first make a hook to get our smart account address. Let's make a hook. And let's call that use smart account, I guess. Use smart account. Okay, so explore onto use smart account. And we will have smart account address set. We'll call that address or undefined. And we'll call our smart account object from our context that we just created. Biconomy context, that way we've got our smart account. And smart account has a function called get account address, but it is a async function, so we'll need to do this under a use effect. Get smart account address. We'll make this async. Account. Get account. Whoops. No. Nope. Sorry, not this. Await smart account dot get account address. Sorry, I had a typo here. It's type string. It's fine because I know this is an address, so let's just this as address, a little bit dirty, but we know what it is. And then we call it get smart account address. And a dependency array, which if the smart account object changes. There we go. And now we should be good. Smart account address. All right, let's test that this works. So in theory, this smart wallet address should change from our EOA address into the real actual smart account address. Forgot what I put it, so let's just search for it. I think I call it use account, maybe. Oh, we're gonna have to make a couple of refactors here, so bear with me. Rather, let's just do it in the one first, just to make it a bit faster. Let's do it here. Okay, never mind. Good here. Take care of these one by one. And we can actually already see that this has changed. See, it previously was 0xAAAA, now it's this new address, 0x4A. So we already know that we are, in fact, using the Biconomy smart account, which is a good sign. But let's just continue with this refactor here while we're at it. Almost there. And I think after this we should be good. The last one I'm just using it for is connected, so I think we can leave that. Let's double check. Yeah, here account view, I'm just importing it using it for is connected, so I think we should be good. Okay. Let's try this one more time. So I think I'm connected with my, actually, sorry, let me give 1 sec. I need to change one of my environment variables. Give me 1 sec. So now, let's try with a Google login, and let's see. I just want to prove that, again, the smart account wallet address will be different, in fact, from our actual wallet address. So here is our EOA address. Smart account address does look a little bit fishy because this looks quite similar to what we had last time. Let me try refreshing to see if there's any difference. Okay, we now have a different one, but I just want to make sure that yeah, okay. Let's stick with this for now because we have, let's see, let's move on to actually calling, sending a user op, which is what we're going to be doing instead of sending transactions directly into the mempool from our provider. We will be sending a user op to the Biconomy bundler and paymaster. So let's do that instead. First, I will want to define a more general function called use contract write as a hook. I'll call it use contract write with AA for account abstraction use contract write with AA. Okay, so what's that going to take? Right with AA. That takes a array of unsigned transactions, which are of oh, you know what? Let's define that type. Types, and let's call export type unsigned tx, and it has a to field. It has a data field. This is going to be our function selector plus the encoded data. Just to be explicit, because this is technically types, although kind of make them all the same here. And potentially a value. This is if we want to send Ether with our request. And that looks good. So here we will now have an array of unsigned transactions. And what do we do with it? First, let's get our smart account. No, sorry, that's not what we want. We want the context actually. So let's smart account equals use context, and we'll get the Biconomy context. We have the actual object. And this could be undefined, right? Yeah, or no, if smart account. And we'll call the function called mutator. We'll have this later, don't worry. Otherwise, so this will be a function that we attach onto our transaction button. This for now. Okay. First, we'll build the user up using this bundle. Get the response. out, send a user up. So this is us sending this out to the paymaster, and let's log this. And we can emit toast with the let's check confirmed. Transaction with the hash, and I think we should be pretty good here. So, oh, and then let's return it. Okay, so this will be our general hook for sending user ups to the Biconomy paymaster. Now let's define our actual transaction hooks. Whoops. So we will want to activate these swap buttons here. So we go over to the trade page. When we want to buy or sell, for example, this is on Gorley testnet, by the way. This button, I think it doesn't do anything right now, so I click it, doesn't do anything. So we want to attach this to the transaction. So let's get on that. So under our hooks, let's make another folder for Zima hooks. And we need to handle both sides. When we are buying the token, in this case buying USDC, we will be selling ETH, so we need to be sending native ETH. On the other hand, if we are if we are selling the token and buying ETH, we'd be receiving native token, but we need to be transferring out the ERC20. So in the old school traditional method, we would need to send out two transactions here. We need to send out a approved transaction firstly, and then the actual transaction itself, the actual swap itself. How do I get rid of this? Whoops. With account abstraction, we have this concept of bundling together transactions. So this is a huge UX improvement for users because we can now bundle our approve transaction as well as our swap transaction into one bundle and execute it in one click. So let's do that first, and then let's see where we go from there. Let's make a hook. Let's make a hook. Call that use write use approve and swap exact tokens for ETH.ts. Okay, const use approve and swap is a long hook name. Sorry, tokens for ETH. I think we need some arguments here, but let's just go with this for now. Let's get our chain info first. So our own hook for getting our contract addresses. We will need the Zima router address. Goes to chain info. And let's just make sure that that's in an actual address. And let's start writing out the data. So approve data to encode function. This is a Viem function, which basically converts the arguments we put into it into an actual the data bytes that we need to feed in to the transaction. So that takes in a ABI, which here we're going to use the ERC20. It takes in the function name, which is approve, and the arguments, which is going to be the Zima router address, and then okay, this, and I think we need the amount too. So this is where we start needing the arguments. I'm just going to copy paste this thing because I have this written somewhere else. And we'll import the import address as well. And we want the amount in. So we want to approve only exactly how much the user wants to send. And let's make the let's build that transaction object. So approve transaction 2 goes to the token address, which is the ERC20 itself. Data is this approved data that we just wrote down, and no value needed because we are sending ERC20, not native token. And then now let's build the swap argument. Amount in, amount out, min, deadline. And do the same thing we did for the approve, except we'll call this swap exact tokens for ETH data code function. And this takes the Zima router ER's API. Function is called swap exact tokens for ETH. And arguments is going to be our args. And let's build that transaction on swap exact tokens for ETH 2. This goes to Zima router address. And the data will be swap exact tokens for ETH data. And I think we're good. So now let's call our use contract write with AA, mutator, contract write with AA, proof TX. So we will put both of these transactions together. So the bundler will bundle these together and then execute both of them right next to each other, which is exactly what we want for good UX for the user. And I think we are ready. Actually, you know what? Let's do the other side as well too, which is use swap exact ETH for tokens. So we're gonna have a little bit difference here. On this side, we don't need to bundle two transactions together. We only need to do one because we don't need to do the approve because we're using native ETH. So this should be a bit easier. Exact ETH for tokens. And I'll paste in our arguments here. Use the same thing that we did here, the Zima address, router address, copy paste that in. What else do we want in here? We don't need this anymore. The args. Exact ETH for tokens data. Same thing, we'll encode function data from Viem taking in the schema router ABI, swap exact ETH for tokens and our args, and exact ETH will build the transaction to Zima router data. Except this time, one difference is we are going to include a value because we are sending in native ETH, which is our amount in. I think we should be good. And let's just send this. Whoops. I need to change this. Exact. And import. Okay. And I think we're ready to give it a test. Let's give it a try. We'll go to our button here for buying and selling. Sell button. We got this buy and sell token here, so we need to populate that with the actual function that we want. So let's go down here. Just write approve, use approve and swap. And what are the args? I think here I call it user address, but let's just rename this to a lot of args coming up. See how that looks. And we'll do the same. Let's just call this sell quote token, and we'll have the same exact for tokens. Cool type. Okay, so now we've got both our functions and we just need to plug it in. Let's see. Name these correctly. Okay. By quote token. All right, let's see what will happen here now. Is there some error here. Okay, this is our favorite. So this is just a test ERC. Oh, okay. Schema router, uniswap exact ETH for choice. Did I call something wrong here? Exact. Might have put too many args, did I? Oh, yeah, here we go, this amount, and we didn't need that. This wasn't supposed to be in the args, this was supposed to be in the value. That was the issue here. I think we should be okay now. Okay. Work. And let's try, well, let's try both. Let's try selling USDC and buying ETH. See what happens here. This. Oh, right, and I already see a UX issue here. Well, let's see if this confirms first. So I can see the transaction is actually sent right now, and the transaction is confirmed. However, we have an issue with this button here, which I don't like that this button is not disabled while the transaction is in flight. Let's fix that. Should be a pretty easy fix. Let's jump into our use contract write function here, and we will add another field in here called pending, set is pending. All right, and we'll accept that use state boolean, and we'll say that's false. And that will only ever be set true while this function is running. There we go. And also here, set is pending, false. There, and we want to return this so that our component can read this. Pending, it's false. Here is pending. This looks good. And let's get that from our other component, which is our buy sell button. is pending. What can I call it? It's pending cell. Oops, it's pending cell. Oh, I need to return those also. Up here, yeah, good. And same thing for the other swap. There we go. And now, yeah, we have access to it. Okay, same thing here. It's pending by. I actually had this. I already kind of anticipated this earlier, so I had this commented out, but now we can actually add this in, which is if is pending by or is pending cell, then our modal will, then our button will display this transaction pending message. So let's try that again and let's see. Let's try the other way around since we did test selling the token and buying ETH. This time we are selling ETH and buying the quote token. And let's see what happens now. Yeah, so now we get this transaction pending. And you guys aren't actually able to see this because I have this window, because I'm sharing this window, but there is actually a pop-up right now that is popping up a signed message. This is something that I don't like about particle auth, is that it pops up this message asking for the user to confirm signing the message. Now that's fine, I think, as a default, but for us, because we're doing a mobile application, remember that our users are on mobile, and when they get that pop-up, it's going to switch them to another window, and that's pretty bad UX. I have talked to the particle auth team, and they did mention that they are working on a solution where they will either have that confirmation window in-app, so in the same window, or give the dev a option to disable this confirmation window altogether. I would prefer the latter, so let's hope that they're able to deliver on that, and then we can start implementing that to pass on the UX improvements to our user. So with that said, I'm going to confirm this transaction. I'm going to take a couple of seconds, and it should pop up with the transaction confirmation here. So that aside, we have shown that we are using a social login here. We're able to do all these transactions, and we never needed to open up our MetaMask, which was a big pain point previously. So with account abstraction, this is a huge UX improvement for users. And that is, yeah, there we go. Transaction confirmed. Wrong Gourlay network, which is a little bit slow. But yeah, that is transaction confirmed. So that is Biconomy abstraction for you. I think we'll stop the stream here because we've done quite a lot today. Again, if you like the stream, please make sure to like, comment, and subscribe. That lets me know that I should be doing more of these videos, and I do hope to be making more of these. So that's a wrap for today. I will see you guys in the next stream. See you guys.